Okay, folks, section 10.8, graphing systems of linear inequalities. Now, in the last section, we learned how to graph one linear inequality. Now we're going to learn how to graph two or more, all on the same graph. And the places where their graphs overlap, those sections, those sectors, okay, those regions, that's where the points are that solve both of the inequalities, okay? So let's look at what we've got here. It says graph the solution set of the systems, all right? So I've got two inequalities. Let me get that out of the way, okay? I've got the red one and I've got the blue one. I'll do that first one in red. So I've got y minus x minus 3 is less than or equal to 0. Remember, whenever I'm graphing linear systems, okay, I want to put it in y equals mx plus b form, okay? All right, so I want to get y by itself. Add 3 to both sides. Y minus x is less than or equal to 3. Add x to both sides, okay? Y is less than or equal to 1 over 1x, because I want to graph this thing, so I need that to be as a fraction so I can see my rise and run, okay? So that's the red one, all right? Now, I'm going to go ahead and graph it. First thing I do is put a dot on the y-intercept, which is at 3. I'm going to go up 1 over 1, up 1 over 1. All right, good, nice. Now, let's see. Is it dotted? No, it's going to be solid because it says it can equal the line, okay? So I need a solid line going through these points. Let's see if I can do that. Not too bad freehand. Not too bad. Now remember, it cuts the y-axis into the blue side and the green side. Green side's the left-hand side, and it says y is less than, so I'm going to shade over here on the green side. All right, let me just take my time. No need to rush. Okay. I know that all of these points inside the green shading solve that inequality. Okay. Now, let's take the blue equation, or the blue inequality. I've got 2x plus 3y is greater than negative 6. And I want to put it in y equals mx plus b form. So, subtract 2x from both sides. All right, subtract 2x. Now I've got 3y is greater than negative 2x minus 6. All right? Then I'm going to divide everything by 3. Everything gets divided by 3, and I get y is greater than negative 2 over 3x minus 2. Okay? Now, my y-intercept is negative 2, so I'm going to put a dot on negative 2. All right? Then the slope is minus 2 over 3, so that means I go down 2 over 3, down 2 over 3, down 2 over 3. Over here, back 3 up 2, back 3 up 2, back 3 up 2. Now this one has to be a dotted line because it did not say it could be equal to the line. Okay? Now the blue line cuts the y-axis into this part. Okay, that's the greater than part. And this part. That's the less than part. Which side of that blue line do I want to shade? Well, it says y is greater than. So I'm going to shade that on the side where y is greater than the line. Now, the blue section, the blue shaded part, is all the solutions to the blue inequality. I'm sorry, I lost the power of language there for a moment. Okay? Now, where they overlap, that's the collection of the points. So that would be all of this section over here. You know what? I'm going to change. Watch this. Check this out. All right? I'm going to change the width of my pen. So this section is where they overlap, and that's the region of points that solve both inequalities. Done. Okay? The green down here, this solves the red. All right? This up here solves the blue. The real thick blue solves both of them. All right? Nice. Any point in the real thick blue, if we plug it in to both of them, they would be true. Okay? Now let's look at the next one. All right? Same thing. Same thing. I've just got 3 that I've got to deal with here. What's the solution to this system of inequalities? Where do all 3 of them overlap? And I'm going to show you a little trick that I use here that helps me keep things straight. Okay? Remember, we want everything in y equals mx plus b, right? Okay, and it looks like all of these are. Thanks, Mr. C. You put them all in order for us already. So now all we have to do is graph these things. Hey, you're welcome. Happy to help. Let's look at this first one. The y-intercept, you know what? I'll call this will be the red one. Okay. Y-intercept is -3, that's right here. I go up 3, and over 4. Okay, up 3, over 4, down 3, back 4, down 3, back 4. Okay, those are on the line. It can be equal to it, so it's a solid line. Let's see if I can draw a solid line. Not bad. Not bad. Okay, and it says y is greater than. Well, that means that I'm going to shade on this side. I'm not going to shade the whole thing, though, because that can get confusing when I've got 3 lines up there. Okay? I'm just saying that every point in this section over here, right, solves the red one. Okay? Now, we want to see where they all 3 overlap. Let the next one be the green. Okay? Good. It, too, has a y-intercept of -3. Okay, and its slope is -3 over 1, so that means I go down 3 over 1, down 3 over 1. How about back 1, up 3, back 1, up 3, back 1, up 3, back 1, up 3. Okay? Now, this one doesn't have an equal to, so it has to be a dotted line. Okay? And remember, it cuts the y-axis into 2 parts here. The less than part down here and the greater than part up here. Okay? And it says we want the y's to be greater than. Okay, well that means that I'm going to shade on this side of the line, because that's the part that includes the greater part of the y-axis. But notice I only shaded in the portion that is also true with the red. I didn't shade down here, right? Because that's not a part of the solution to the set. Right now I know it has to be in this area, right? Because that's where green and red shade. Okay, but let's see where blue shades. All right? Now, the y-intercept is 2, so go up 2. So right here. The slope is down 1 over 2. 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 Back 2 up 1, back 2 up 1, back 2 up 1, back 2 up 1, back 2 up 1. Okay, there we go. There's the line. And it says it can be equal to it, so I'm going to make this a solid line. All right? And it says that y is less than. So I need to shade where the y-axis is less than. That would be on this side of the line. Okay? All right. Now, do you see what I've got here? And I'll do this in black. I've got this little triangle. Okay? It goes right here. And all the points in this section will solve all 3 inequalities. Now, one thing I do want to point out. Let me back up. This is dotted. So no points on that green line would solve it. But everything inside here, inside the triangle, everything's solid. Any point that I pick out of there solves all 3 inequalities. Now, let me back up just so we can see what's in there. Do you see that this point right here, that point is an x of 1 and a y of 0. It's inside the shaded region, okay? So that means that this point, right, that's inside the shaded region, 1, 0, it's going to solve all 3. Let's see if it does, okay? That means that 0 is greater than or equal to 3/4 times 1 minus 3. Okay? 0 is greater than or equal to 3/4 minus 3. 0 is greater than or equal to 2 1/4, negative 2 1/4, negative 2 1/4. Okay? Or negative 9/4. That's true. All right, for this one, that means that 0 is greater than negative 3 times 1 minus 3. 0 is greater than negative 3 minus 3. Whoa, 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 hang on. 0 is greater than, negative 6. That's true too, all right? Now I'm going to try the last one here. That means that 0 is less than or equal to negative 1/2 times 1 plus 2. 0 is less than or equal to negative 1/2 plus 2. 0 is less than or equal to, that's 4/2, it's less than or equal to 3/2. And that's true also. Okay? That one point solves all three of these equations because it's inside the shaded region for each one of them. I think you've got the idea. All right? Good job, guys. Get to work.